Hello friends. So today we'll continue with problems on Castigliano's theorem. We'll take up another standard problem. Determine deflection of free end of cantilever beam of length L carrying UDL W. So this is the cantilever, this is the UDL. Let this length be L. So we are required to calculate deflection at this point. And as per the Castigliano's theorem, we need to have a point load at the required point, or we have to apply a virtual load. So we will be applying a virtual load at point A. Let this be point A, point B. We require to calculate deflection at free end. Therefore, apply imaginary load at free end. Let that imaginary load be Q. Apply a imaginary load at free end. So what is the procedure? Differentiate the equation. Differentiate the strain energy equation. Next, set the imaginary load to 0 because this load does not exist. So I am going to set that to 0. Then integrate the equation. So these are the steps you have to follow if there is no point load at the required point. Therefore, strain energy is given by equation 0 to L m square by 2 EI dx. For unit vertical imaginary load, from Castigliano's theorem we have delta is equal to dou u by dou p, partial differentiation of strain energy with respect to load. Here I have load I have taken as Q. So dou u by dou Q. And strain energy I am having the equation m square by 2 EI dx. Now let us substitute the values. Therefore, delta is equal to dou u by dou m. So that I will write dou u by dou q, not m, dou u by dou q. So I will write the equation for u and differentiate it. 0 to L dou by dou q of m square by 2 EI dx. So this we have to differentiate with respect to q, and this I am having by equation 0 to L differentiation of dou q, or differentiation of partial differentiation of m square is 2m dou m by dou q with respect to 2 EI dx. These get cancelled, so I am left with delta is equal to m dou m by dou q by EI dx, 0 to L. Now let me find the equation for m. Moment at any section m. Just look here. Let this be any section at distance x. So moment at this section, again same sign convention, left hand side clockwise is positive, so these loads are anti-clockwise. So moment at this section because of q minus q into x, then because of UDL w into x by 2. So m is equal to minus q into x minus w into x by 2, wx square by 2. So let me find dou m by dou q. Here dou m by dou q is with respect to q. So I am left with minus x. Here there is no q term. So this is 0. So dou m by dou q is minus x. So substitute m and dou m by dou q in this equation. Therefore delta is equal to 0 to L minus of wx square by 2 plus qx into minus x. Same term, wx square by 2 plus qx minus, I have taken it outside, into minus x divided by ei dx. Now here before integration set imaginary load to 0. So I am left with delta is equal to 0 to L wx cube by 2 ei dx. So differentiate with respect to x. So w by 2 ei x raised to 4 by 4 0 to L, or this given me is the answer. Delta is equal to, substitute x is equal to w L raised to 4 by 4 to the 8 ei. So this completes the standard derivation. Thank you.